everybody, there's a small typo in the video that you're about to watch. This letter over here should be a V. So this should say the commutative, associative, and distributive properties are still valid with the rules we've introduced. Enjoy. In the last few videos, we've been introducing a bunch of new rules to work with negative numbers. So for example, if you add a negative, then you move to the left, which is the same as subtracting a positive. If you subtract a negative, you move to the right, which is the same as adding a positive. And we talked about how those rules led to the rewriting rules. And we talked about multiplication and division. So for example, if the signs are the same, then the answer would be positive. For instance, -3 times -5, both of those are negative. So if I'm multiplying, then the answer would be a positive. So -3 times -5 would be positive 15, but positive 3 times -5 would be -15, because in that case, the signs were different, and when we multiply or divide with two numbers that have different signs, the answer will be negative. So these are, new rules that you have to remember. But I also told you in another video that all of these rules were just made up. People just made up these rules, and then we all have to learn them, right? So they better be good rules. Otherwise, what would be the point of remembering and memorizing all these rules that people made if they weren't even good rules? So I'm going to try to convince you in this video that these rules that people just made up are actually good rules, because these rules for negative numbers maintain the validity of the properties that you already know about. So what am I talking about here? The commutative property, the associative property, and the distributive property. Hopefully you learned about those already, and if not, I'll talk about them in this video. But you learned those rules and how they apply to all positive numbers. But now that we have negative numbers thrown in, and we learned some rules for adding, subtracting, and multiplying and dividing with negative numbers, it's a good idea to see if those properties still hold when there are negative numbers thrown in there. Okay? And we're going to see that in this video. So let's start with the commutative property. The commutative property says that for multiplication or addition, if we change the order, we should still get the same answer. So for example, 3 times 6 is 18, and 6 times 3 is also 18. So even though we reversed the order of that multiplication, we got the same answer. In other words, 3 groups of 6 is the same as 6 groups of 3. Okay, we would have 18 both times. Now, what about when we work with negative numbers? Does the commutative property still hold? So let's see. If we do -3 times 6, here we have different signs. So we learned that the answer would be negative when we're multiplying with different signs. So that would give us a -18. Now, if we switch the order, so instead of doing it this way, now we'll do it this way, 6 times -3. Well, we still have different signs here, so the answer is still going to be negative. So you can see that the commutative property still holds for multiplication when we throw negative numbers in there, okay? And I could have given you a couple more examples. So -3 times -6 would be positive 18, which is the same as -6 times -3 is still positive 18. So it works for multiplication. The commutative property should also work for addition. So let's just make sure that it does. What if I had changed this, instead of a multiplication symbol here, what if I had written an addition symbol? So let's see. -3 plus 6. What does that mean? Let's draw a little number line here. Yeah, that number line doesn't look very good, but that's all right. So what does that mean? That means that I start at -3, and then I go to the right 6 spaces, because when I add a positive, I move to the right. Okay, so let's count. 1, 2, 3, 4, 5, 6. Okay, so I would land on +3. What if I do it the other way? Instead of -3 plus 6, what if I do 6 plus -3? Well, I know that if I add a negative, I move to the left. So let me just get up to 6 here on the number line. So this would mean that I start at 6, and then if I'm adding -3, I move to the left 3 spaces. So from here, I'm going to count 1, 2, 3 spaces to the left. And you can see I landed on the same number, +3. And you also could have done that by remembering the rewriting rules. 6 plus -3 is the same thing as 6 minus 3, which again is just equal to 3. So yeah, the commutative property still holds when we have negative numbers thrown in, because I can still change the order of multiplication or addition and get the same answer. Let's talk about the associative property. The associative property, again, works for multiplication and addition. I'm just going to do an example of multiplication here, but you can work it out for yourself with addition if you want to, if you just want to challenge yourself. So, for example, if I'm doing 2 times 3 times 4, but I want to put parentheses around the 2 and the 3, so I do that multiplication first, what would that be? 2 times 3 is 6, so this would give me 6 times 4. So you see I wrote over here 6 times 4, and 6 times 4 is 24. So that's what I get if I put the parentheses around the 2 and the 3. What if I put the parentheses around the 3 and the 4? That means that I should do 3 times 4 first, which is 12. So this would give me 2 times 12. And you see I wrote over here that this is equal to 2 times 12, but 2 times 12 is also 24. So that's what the associative property means. It means if I have a string of numbers and I'm multiplying all of them, I could put parentheses around different pairs of numbers and still get the same answer. And it works the same for addition also. You can do some examples on your own if you want. But what if I throw some negative numbers in there? Is the associative property still going to work? Will I still get the same answer? You can see here that we will. So for example, if I do -2 times -3 times +4, and I put the parentheses around these first two numbers, a negative times a negative, the signs are the same, the answer is going to be a positive, so I would get +6 there. So this would be +6 times 4, so 6 times 4, both of them would be positive, equals +24, okay? Now, what if I put the parentheses around the -3 and the 4? So what if I put the parentheses here? Okay, remember, I didn't change any of these signs, so this 2 is still negative, the 3 is still negative, the 4 is still positive. I just grouped them differently, so I put the parentheses around a different pair here. So now I have to do -3 times 4 first. Now when I'm doing multiplication, if the signs are different, then the answer will be negative. So -3 times +4 is going to give me a -12. And of course, I still have this -2 out front, which is getting multiplied by this. So this is going to be -2 times -12. And now I have same signs here. So remember, when I'm multiplying with same signs, then the answer is positive. So -2 times -12 is equal to +24. So again, you can see I do get the same answer. So the associative property still holds even when we throw these negative numbers in there, and we have to remember all these rules for how we deal with the negative numbers. All right, let's do, for our last example, by the way, again, you could have, if you want to challenge yourself, you can try changing all of these multiplication symbols. You can try changing them to addition symbols. Okay, I'm not going to do that for you in this video, but if you want to challenge yourself, try working all of this out with addition instead of multiplication, and seeing if you get the same answer both times. But I'm going to move on now to the distributive property, which says that if I multiply over addition, so here I'm multiplying the 5 with 6 plus 10, then doing this is the same as doing this. In other words, 5 times, in parentheses, 6 plus 10 is the same as 5 times 6, which I wrote over here, plus 5 times 10, which I wrote over here. So let's do it with all positive numbers. Okay, so for this one, I would do 6 plus 10 first, since it's in parentheses, and that's going to give me 16. And then 5 times 16, which I wrote here, is equal to 80. Now, what if I do it this way? What if I do 5 times 6 plus 5 times 10, right? Sometimes I like drawing arrows here when I'm talking about the distributive property. So for doing it this other way, I would do 5 times 6 plus 5 times 10. So 5 times 6 is 30, which I wrote over here. 5 times 10 is 50. So this would be 30 plus 50. Okay, the 30 there, the 50 here. So this is 30 plus 50 is also equal to 80. So you can see I got the same answer both times. Now, all of these numbers here were, well, I should really focus on this, what I started with. All of these numbers here were positive, and I ended up getting the same answer. Is this still going to work out if we work with negative numbers? Well, let's see. So you can see in this example, I just changed this positive 10 to a negative 10. And now we're going to see if the distributive property still holds. So let's do this first. We have 6 plus negative 10. So I can use the rewriting rules. I know that I can change that plus negative to just a minus symbol there. So 6 plus negative 10 is the same as 6 minus 10. So this is going to give me 5 times 6 minus 10. And then I'll do parentheses first. I'm still following my order of operations. Okay, PEMDAS if you like. So 6 minus 10, be careful, that's not 4, because I'm taking a bigger number away from a smaller number. So I would get a negative there. So 6 minus 10 is negative 4. So now I have 5 times negative 4, which I wrote over here. And now I have to remember my rules for multiplying, which say that if I have different signs, so one is positive, one is negative, then the answer will be negative. So positive 5 times negative 4 is negative 20. I know you guys are getting probably a little bit tired listening to me. Try saying all of this. My mouth is getting tired. So let's just work on the last one here. So now let's do, instead of doing it this way, let's see if the distributive property holds. So we'll do 5 times 6 plus 5 times negative 10. That's a little confusing with that circle still there. So let me erase it. So 5 times 6, which I wrote over here, plus 5 times negative 10, which I wrote over here. So 5 times 6 is 30. 5 times negative 10 would give me negative 50. So I have now 30 plus negative 50. And now I can go ahead and use my rewriting rule again, which says that adding a negative is like subtracting a positive. So I can rewrite this plus negative as a minus. So that's going to give me 30 minus 50. And again, I'm taking a larger number away from a smaller number. So be careful. if I think of a number line here, if I start at positive 30, let me use my pen, it's easier than writing with the mouse. If I start at positive 30 and then I move to the left, maybe that's a little bit too far. Let me try to do it to scale here. If I move to the left 50 spaces, then I'm going to get a negative answer. Okay, again, I would get negative 20, which is the same thing that I got over here. So again, the distributive property does hold. If we do a multiplication over addition here, then we get the same answer, you know, no matter which way that we do it. Okay? And again, you could challenge yourself if you want with, I just made this 10 negative. You could try doing it by making these 5s both negatives. You could try doing it by making both of these 6s negatives. You could do some more examples by yourself if you want. And you should be able to see that, you know, the distributive property, it always works no matter how many negative numbers we throw in there. Okay, so the rules, as we have introduced them in previous videos, they're good rules because all of those properties that you learned about before, the commutative property, the associative property, and the distributive property, they still work. I am tired now. I cannot believe I did all of that in just one take. I didn't have to stop and redo anything. So I'm going to end it there. Have a great day.